Well, hello there, Algebra 1 Essentials lovely human beings. It is delightful to have you there on the other side of this video. I'm Ms. Waite, and I'm going to help you take the next step in studying algebra. So here we have a little warm-up for problems, some simple addition. How about you pause this video and work on these, and then I'll be back, and we'll work on them together. All right. So when you're adding pieces together, adding numbers together, you are actually doing what we're going to talk about today, which is called combining like terms. I'm going to get into all that in just a second. But when you are putting these two things together, whenever you're looking at adding two numbers together, you take a look at what the two numbers are, and then you do the operation that's between them. So in number 1, the two numbers are 2 and 6, and the operation is addition. And you're pretty familiar with adding things up. You could just take the 2 and add it to the 6. And when you do that, you have combined those two numbers using the operation of addition, and you get 8, because 2 plus 6 is definitely 8. Number 2, same idea. You've got a 4 and a 16, and you're going to combine them using the operation of addition. 4 plus 16 is 20. And then for number 3, it's maybe just a little bit more complicated, but you can still add those numbers up. 45 plus 7, you could do it a couple of ways. You could do 45 plus 7 and add them up like this. And then you would just add the 7 plus the 5 and get 12. You put the 2 down here and carry the 1. And then 4 plus the 1 is 52. The other way you could do it is get a calculator. 45 plus 7 is definitely 52. And now in 4, you do the same thing. The two numbers you're trying to combine are 47 and 19. You're combining them using the operation of addition. And you could stack these up and do this way as well, 47 plus 19. And then you would add the 9 plus the 7, which is 16. Put your 6 here and carry the 1. And then 4 plus 1 is going to be 6. And so the answer is 66. So addition problems are combining like terms, and combining like terms is what we're talking about today. So let's do it. At this point, it's time to get your notebook out, pause this video and write yourself a set of questions for at least one set of notes, and then write a summary for another set of notes. If you get in the habit of doing this, you're reviewing notes as we go forward, and so you're bringing the information that you might have forgotten before into the new lesson. Then get a page ready for today's notes. So go ahead and pause the video and take care of your notebook. All right, and here's what you're going to put on your new note page. Your topic at the top is combining like terms. The essential question right underneath that should be, how do I combine like terms? And now you've got some space for some questions, a summary, and you'll take some notes in the bigger space. Oh, make sure you go back to that table of contents and put your topic in there as well. All right, so we're going to start out with some definitions, with some new words that you might not have heard before. They are term, coefficient, like term, and constant term. And then we have an example that I'll show you. So a term is a set of numbers and or variables that are separated by, and I'll, let's see, running out of room, but are separated by plus signs. All right, so I had to pause for a second because I lost audio and had to change the batteries on my microphone, so hopefully you're still with me. All right, so where we were was defining term. Let me get rid of this. Oh, sorry about all that crazy feedback. There we go. So a term is a set of numbers and or variables that are separated by pluses and minuses. Oh, that's terrible. Sorry. Boy. Turn this down a tiny, maybe that'll help. Oh, you guys, this is not going very well, is it? Let me turn down this bit. All right, hopefully that'll be better, and hopefully you can still hear me in a math sentence. In other words, an expression. A set of numbers and or variables that are separated by a plus and minus in a math sentence. A coefficient is a number in front of a variable. A like terms are terms that have the same variables raised to the same power. And then you have what's called constant terms. Constant terms are numbers with no variable. So those are the pieces that we're looking at when we look at this expression here, 3x squared plus 4x minus 6x plus 2x squared minus 12. We are going to identify the pieces. Each one of these sets of numbers and variables that are separated by these pluses and minuses, these are terms. That fits the definition of term. They are sets of numbers or variables that are separated by pluses and minuses in a math sentence. So 3x squared is a term. 4x is a term. 6x is a term. Those are the things that are separated by those pluses and minuses. Okay, so let me get rid of this part. Now we want to look at what the coefficients are. Well, remember that the coefficients are a number in front of a variable. And so in this expression, we have 3, that's a number in front of a variable, a 4, which is a number in front of a variable, a 6, and a 2. These are coefficients. Okay? The numbers that are in front of a variable. All right, the next thing are like terms. Now, like terms have the same variables raised to the same power. So in this mathematical sentence, you have a 3x squared. That's a term. And notice that this 4x doesn't have the little 2. It's not raised to the same power, so it's not a like term with 3x squared. Neither is this 6x. Those are not like terms. But check out this 2x squared. See how it has the same variable raised to the same power? That means, and the 12 doesn't have any variable at all, so the 3x squared and the 2x squared are like terms. Can you see another set of like terms in this expression? Notice that you have the 4x and the 6x. They both have the same variable raised to the same power, which in this case doesn't look like there's any power at all. And so these guys are also like terms. And that 12 sort of sits there by itself. There is nobody to match it up with. It's almost like thinking about like terms as people being on the same team. They're wearing the same uniform. And so you have the x squared team, you have the x team, and then you also have that 12 who unfortunately doesn't have anybody to be a team with. But that's how you can decide what like terms are. And then lastly, we are going to go ahead and talk about this 12. because that 12 is a constant term. Because, like the definition says, it's a number with no variable. It's a constant. All of these things are going to come into play when we're thinking about combining like terms. The terms are what you're going to combine. The coefficients are going to be how much they combine. The like terms are going to get combined, and the constant terms will get combined too. All right, so the first thing to do is to kind of keep going with identifying terms, like terms, coefficients, and constant terms. So we have this expression 5 minus 2x minus 3 plus x. Now we have some terms. Remember, the terms are the numbers and letters together that are separated by pluses and minuses. And so the terms we have here are 5, 2x, 3, and this x. Those are the pieces that are separated by pluses and minuses. Now we have some like terms. Remember, those are the guys that are on the same team. And so we have 2x and x. They both have x's, and so they are like terms, 2x and x. But also you can combine constant terms by looking at them as like terms as well, because you can combine a 5 and a 3, and so these guys are also like terms. We'll talk about what that means in just a bit. And lastly, we can identify the coefficients. These are going to be the numbers that are right in front of variables. So notice that you have a 2 in front of this x, and so you have a coefficient of 2. But this one, this x, doesn't appear to have a number in front of it. But it kind of does, actually. There's like an invisible 1 in front of that x. For some reason, mathematicians don't write the 1 when there's only one of something. But we can pretend that it's there and say that there is a 1 in front of that x, because there kind of is. Anyway, so that's how you identify terms, like terms, coefficients, and constant terms, and how we can think of them as like terms. All right, so let's do this again. We're going to identify the terms, like terms, coefficients, and constant terms of each expression. So let's start with number 1, 4y minus 6 plus 3y. Let's identify the terms first. Those are going to be the guys that are separated by the pluses and the minuses. And so we have 4y, and we have 6, and we have 3y. Those are your terms. The like terms are the ones that play for the same team, the ones that have the same variable raised to the same power. And so notice that that 4y and that 3y both have just a y. They're not raised to any power at all. And so 4y and 3y are like terms. That 6, which is a constant, is going to be kind of hanging out by itself. So there's no like term for that. When we're looking at coefficients, we're looking for the numbers that are hanging out right in front of letters. And so we have a 4 in front of a y, and we have a 3 in front of a y. And those are the only two coefficients. When we're looking at constants, we're just looking for a number that's hanging out by itself, and in this case, the only one is a 6. Okay? And we can do the same thing with number 2. What are our terms? Well, they're all the things that are separated by pluses and minuses. And so you have a 9, you have a W, you have a 5, and you have an 8W. Those are your terms. Your like terms are the ones that play for the same team. They have the same variable raised to the same power, and they could also be constant terms. So here's some like terms. 9 and 5 are like terms because they don't have a variable at all. And then you also have W and 8W. Those are our two sets of like terms. Coefficients. Coefficients are the numbers hanging out in front of letters. And so let's see, what do we have in front of that W? It's sitting all by itself. There's no number in front of it. So there's sort of an invisible 1 there. And then we also have an 8 in front of the other W. So that is our coefficients. And then we have a couple of constant terms. These are the ones that don't have any letters at all. Do you see them? We got the 9 that has no has no variable with it. And then we also have the 5. So there you go. These are the pieces of an algebraic expression, the terms, the like terms, the coefficients, and the constant terms. And we're going to use what we know about those things to simplify expressions by combining our like terms. So now that we can do that, we can combine the terms that are like, the ones that are on the same team. And remember, like terms are terms that have the same variable raised to the same power and constants. Constant terms can be combined as well. Okay, so here we go. When you're presented with an algebraic expression, which is what you're looking at now, it's like a math sentence, you can simplify these. You can make them smaller by combining like terms. So the first thing to do is to identify your like terms. And I like to use colored pencils for this. I circle in different colors the like terms, and that helps me identify them. So what I notice, first of all, is that I have two terms that have an M in them. And so when I circle them, I circle the first one, 5M, and then I'm also going to circle that 3M, but I'm going to be careful because I'm also going to circle the minus sign in front of the 3M, and I'll tell you why I do that in just a second. So there is a set of like terms. I can also see that there's an 8 and a 7, which I'm being careful to circle the operations in front of those, because what that does is tells me how to combine them. And what you do to combine like terms is basically you just operate with the coefficients. So for example, if I'm just pulling this part out, I have 5M's and I'm subtracting 3M's. Now this is like saying I have 5 pencils and I'm going to give you 3 pencils. How many pencils do I have left over? I would have 2 pencils, right? Because 5 pencils minus 3 pencils is 2 pencils. I can do the same thing, just replacing that pencils part with an M. If I have 5 M's and I give away 3 M's, how many M's do I have? I have 2 M's. And now I have combined these like terms. And you see why it was important to circle that minus sign in front of the 3, because it told me how to combine those terms. And now I can do the same thing with the 8 and the 7. I have a positive 8 minus a 7. And just like we did in the warm-up, we can combine these like terms, and we can say, what is 8 minus 7? 8 minus 7 is 1. Now, how do I put these together? Well, since this 1 is positive, I can just put a plus sign between them. And I have 2M plus 1, and that is my answer. I know that I'm done. I know it looks really weird, but that's the correct answer. I know I'm done when I don't have any more like terms. See how the 2M and the 1 are not like terms? One has an M, one doesn't. They can't be combined, and so I'm done. Okay, we're going to do a few of these so you can see how it works. All right, so let's simplify 4y minus 6 plus 3y. Well, I'm going to circle my like terms. Notice I have a 4y here and a plus 3y there. I can combine those, and the negative 6 doesn't have anybody to combine with. So I can say to myself, what is 4y plus 3y? Well, it's like 4 pencils plus 3 pencils is 7 pencils, so I have 7y. And then since I didn't do anything with the negative 6, I can't combine it with anything, I can just bring it right down. Now let's look at this expression. Do I have any like terms? One's got a y and one doesn't, so I don't have any like terms, and this is done. You're going to have to get used to math looking a little bit weird, and you're not always going to get this pretty whole number at the end, and that's okay. You're taking your next step in higher level math, and so things start to get weird. Math is funny like that. Okay, let's do some more so we get the idea. All right, so now we have 9 plus w minus 5 minus 8w. So I'm going to circle the like terms. I have a constant, 9, and I have another constant, minus 5. Those can be combined. And then I have a w minus 8w's. And so I can combine those. Combining 9 minus 5 gives me 4. And then combining w, 1w, minus 8w's gives me, whoops, I need the green, negative 7w's, right? And so there's my answer. I'm done now with this. Because even though it looks weird, I can't combine a 4 and a negative 7w because they're not like terms. Just circle the terms that are alike and combine them using the operations that are in front of the coefficient. All right, here's another one. 12r minus 8 minus 12. Let's see. 12r, is there any other term that has an r in it? So no, there isn't. So this 12r is going to end up being part of our answer. So I'm going to go ahead and bring it down, 12r. I don't have anybody to combine it with, and so now I'm done with that one. Now I also have negative 8, which is a constant, minus 12, which is another constant. And remember, constants are like terms. And so I just operate negative 8 minus 12. So starting at negative 8 and getting more negative by 12 places. So that is going to be negative 20. And that's done because I don't have any more like terms. 12r minus 20 is the correct answer. Okay, here's another one. We just keep looking at it until it gets familiar. That's the thing about math. It looks weird at first, and then you do it enough, and it stops looking weird. Math isn't really, math is sort of like just having to get used to things a lot of the time. So I have 12r and 3r is a like term. Oops, I forgot to circle the plus sign in front of that 3r. Miss Wait. 12r plus 3r. Well, what's 12 plus 3? 12, 13, 14, 15. And so when I combine those like terms, I have 15r, and now I'm done with those two. And I can identify another set of like terms. There's 5 minus 5. What is 5 minus 5? It's 0, right? Now I could write plus 0 here if I wanted. There's nothing wrong with that. But if you're not adding anything, there's really nothing to do. And so 15r is your answer. Here's another one. N minus 10 plus 9n minus 3. Let's identify a set of like terms. I've got an n plus 9 more n's. 1n plus 9 n's is 10 n's, and I'm done with those guys. And now I can go back and find some other like terms. Here is negative 10 minus 3, which is negative 13. And since I know that I don't have any more like terms, that is the answer. That's really it. That's all there is to it with combining like terms. It looks weird, but really you're just looking for the things that match and putting them together according to the operation that's between them. A little practice will get you seeing this, and you'll do great, I promise. You have a quizzes, so go to that website and complete the assignment called Combining Like Terms. There's your essential question for the day. How do I combine like terms? Hopefully you can answer that question. If you can't, then maybe watch the video again. Maybe a little bit of practice on the quizzes will help. And don't forget, we have optional class times, and we also have office hours. You can find that information on Google Classroom. All right, friends, I hope you're doing well and you're staying healthy. And, oops, what happened? And hopefully I will see you in the classroom someday. All right, bye-bye.